So now let's talk about residuals. I have my regression equation. Y hat, my expected value of x, or expected value of y, is equal to bx plus a. And that, of course, describes a line, right? My line of best fit for my data. My predicted variables of, my predicted values of y based on my values of x. And look, here's the thing. That does not perfectly describe my data. It gives me some idea of what my data look like, but it does not perfectly describe them, right? Because we know that this is really a scatter plot. Maybe one or two or three or more end up on that line, but probably not all of them. If it was a perfect relationship, then I probably don't even need to do this, right? But there's some sort of scatter around here. And what's interesting here now is there's an error. There's going to be an error between my predicted value of y, which is on this line, and now my actual value of y. So for every value of y, there is a value of error called y hat minus y. Right? This is the difference between the predicted value and the actual value. We call this the residual. We could also call it the error, but we often call it the residual. Right? And a residual is the difference between a predictor score, or the predicted score, and an actual score. Now, if I were going to add all of these up, right? So there is a residual for every single value of x. There is a value of y, and so there is a residual. There's some difference. Now, in some cases, if y is on this line, then it might be 0. If it's something more or something less, right, it's going to be something more or less. But for every value of x, there is a value, there is a predicted value of y, there's an actual value of y, and there is a residual. If I was going to add all these up, in theory, assuming that all of my error is random, then it ends up being 0. Right? That if I add all these up, all the residuals should come out to be somewhere around 0 because they're randomly scattered around the line of best fit. So just like when we do with our different scores when we're doing our t-tests, our variance equations, is if I square this, I get what we call the squared residuals. So if I were to sum this up, I'd have the sum of squared residuals. OLS regression, or ordinary, I don't spell very well, least squares. OLS regression gives us the line of best fit, right? This is a method of analysis that gives us the line of best fit that gives us the least squared residuals, right? And that's where the name comes from. That this is the one line that has the smallest residuals of all the possible lines that I could draw. So it's the least squares, the least residuals. These are minimized. So we know that error, those residuals, right? Remember I talked about in the very first, or one of the very first week's videos, I talked about embracing the errors. These errors tell us something more. They tell us that there is something other than x that predicts y. There's some other value out there, some other variable that's out there, some other factor. All of those are caught up in here. So that's why we can also call this the error. That this encompasses all of the stuff that we didn't account for in our relationship between x and y. There are going to be other things. And the question for us isn't are there going to be other things? It's about how big they are. And that's going to give us an idea of how good our prediction is. So if I'm curious how good of a predictor x is in predicting y, I can look at how big these errors are. And of course, just like when we did different scores, just like when I did variance, I can take some variance of here. In fact, I can take the standard deviation of the residuals. And this is called the standard error of the estimate. Right? So I have all these residuals, and just like any other number, they have some sort of distribution. probably a normal distribution. In fact, that's kind of a underlying assumption here. There's some normal distribution of errors of these y hat minus y of our residuals. And if I take the standard distribution, or excuse me, the standard deviation of those residuals, that tells me this is horrible handwriting, sorry about that, the standard error of the estimate. And the standard error of the estimate is a measure of how good our prediction is. How much error is there in the prediction? We find that from the standard error of the estimate. It's the standard deviation of these points, of these lines that describe these points around the regression line. The standard deviation of the errors for each particular one. Now, the standard deviation of y hat minus y, or the standard error of the estimate, has a range. And broadly, it ranges from 0 is going to be less than the standard deviation, the standard error of the estimate, is going to be less than the standard deviation of y. Right? So the closer I am to 0, the closer the standard error of the estimate is to 0, the less error I have, the better the predictive value of my regression equation. The closer this is to the standard deviation of y, right? So if there is no relationship here, or if x is a poor predictor of y, my errors will be closer to just the standard deviation of y. And that's what's going to happen, right? So if I have no relationship, right? So let's take the case where I have no relationship between x and y. In this case, I will still get a predictor line, right? And it's going to look like y hat equals 0 times x plus some a, right? And it's going to be located, in fact, this a is going to be the mean of y, right? So located at the mean of y, I'm going to get this straight horizontal line with a 0. At that point, the standard error of the estimate is the greatest it can possibly be, which is the standard deviation of y, right? The standard deviation of how far y gets from that mean line. If I have a perfect relationship, then I have no errors. So now we can see that that's why the standard error of the estimate ranges from 0 to the standard deviation of y. So again, standard error of the estimate is the standard deviation of the residuals, and that describes the predictive value or the strength or the accuracy of my prediction in my predicting y from a regression equation including x.